Hello everybody, so welcome back, and in this video we're going to continue on from our custom component and at least get it up and running properly. And what do I mean by this is that at this current stage we don't actually have a working component. It works by itself, you can build it, but you can't actually parent it or have another component parent to it without it actually breaking, essentially. It will just error. And what do I mean like this? Let's have a look. So in Maya, what I've got here is our custom component. And I've got the God node. I've parented the custom component to the God node and everything just works. But as soon as we actually do a build and we go to skeleton mode, we immediately get an error. And the question is why? Well, we actually rely on the inputs and outputs of your component to determine how to connect everything. So it's finding guides because it's done automatically for you, but as soon as you go into the next build stages, it's essentially going to fail if you don't have inputs and outputs. That's actually a pretty easy thing to fix. So let's jump back into code and get this done. What we want to do is now add inputs and outputs to our component. There's two different ways of doing this, and one way is to do it purely in code. The other way is to do it directly in the definition. I'm going to show you both ways because it's actually pretty simple to do directly in code as well. So what we'll end up doing is do it in code first, then I'll actually port it over into the data, so the definition, and then just strip out the code that we don't need anymore. Now, there is one thing that we have to worry about, and that is setting up all the positions and everything, but that's going to be pretty straightforward as well. So first thing I'm going to do is override two different methods. First one is going to be set up inputs. And all we want to do is for super on that, and auto completion, go away. Now, we just want to do outputs. And we're also going to call super on that. So what we want to do now is essentially set up our inputs. Now we're doing this in code, so I'm not going to use the definition for this. We are going to use the guides to essentially position everything. What we basically want to do first is grab the definition, because we're going to need that to determine what the positions are, or what the IDs are going to be for all this. So the next thing is we're going to create a single input. Now, when it comes to inputs, you essentially have inputs just for the ones that you want to connect to. So this is the locations where you're going to have space switching, or it's going to be like as a pre-built solution. And typically you're only going to have one input that's going to be forced to be your root. Now, your root input is what's going to be utilized for all your connections for your component going in and out from one component to another. So what we're going to do in here is going to now create our input. So go to definition dot input layer dot create input. And if we have a look at the base method for this, it's just an info structure. So this is all just a dictionary. What we're going to do is pass in the ID. Now we're going to you can use whatever ID you wish to use, but it needs to be something that you can be consistent with. So in this case, I'm just going to use ID, ID of parent. Then I'm also going to give it a name. And name doesn't really matter so much right now. We'll deal with that a little bit later. So I'm just going to call this parent input, just for the time being, as a placeholder. So now we have our input. That's all we really need to do. But the thing is that if we actually run this method multiple times, it potentially could actually create the input multiple times. So I'm just going to say if input layer input, and just get parent. I'm just going to say not. I'm just going to create the input. Now, what I want to do is, if we have a look at the setup inputs, just so you know how it runs, because we're going to move this super method here down to the bottom, right? And the reason why is because what I kind of want this stuff to do is you have control over how you want your component to be built and the logic and so on. What the setup inputs does, the base class, is actually utilizes the definition and loops over it and actually generates all your inputs in the scene. So if we have a look at this, you can see that basically it looks over the inputs and constructs the input directly in the scene, and then purges anything that's not in the scene or in the definition, so everything lines up. It's basically just doing a diff. It also then sets up all your input settings and so on that you might have on that side as well. The best idea here is to use setup inputs last, after you actually create everything in the definition. This is really useful. We do this in a lot of components when you have dynamic kind of setups. The last thing we need to do is take this scene input that we just created and put it in the right position. So at the moment, we're just basically putting in the scene, and that's all we're doing with the definition. If you try to update the position in the definition, update the transformation within the definition of the input, then Hive is not going to update those positions. And at least at this point in time, maybe I'll deal with that in the future if there's no circumstances where you don't want that to happen. So at the moment, I've just left it as you have more control over that. And you do that manually. So what we're going to do now is grab the input from the scene. So you can do this, go to input node, and I'm just going to grab the parent, and then I'm just going to set the wall metrics. And you can see here is that all we really want to do is go to input guide from here. So what we can actually do here is I'm just going to put this on a separate line. So guide equals definition dot guide layer dot guide, and I'm just going to grab the parent, not the alpha, because that's going to be the very first one. I believe that's what we named it. Yep, input ID. Then we just grab that, go transformation matrix, and we don't want the scale coming from the guide because the user can scale this kind of stuff up uniformly, non-uniformly, but we don't want any of that going into our rig. So just go transformation matrix, scale it as false, and you're good to go. Now, transformation matrix actually returns you the MFN transformation matrix class from the Myers API. But you can actually just pass that in because the way that transformation matrix does work is if you pass it into a method that actually takes a matrix, it'll do the casting for you. That's all we really need to do for the inputs. Now we should be able to, actually, there's one more thing that I forgot, which is root as a flag is true. I believe that's the right flag. And that just specifies that this input is going to be the main input for your component. So when you connect, say, a parent component to your custom component, it's going to know, hey, from that component, this is the only input to connect to. That's the only one you can connect to. Everything else is basically built for things like space switching and everything else. Anything else you want to use it for. Now, if we go back into Maya, and I'll just do another rebuild, and I'll just reload. Now, if we create two components, so our God node, and if I did everything correctly, should be able to position it, constrain it, like so, and then do a build. And you can see everything's now connected. And if we go into our custom component, you can see in here we have our input, and you can also see that it's actually constrained. And if we have a quick look at where that constraint comes from, it's coming from the offset of the God node. So we're essentially doing exactly what we're supposed to do. So now if we go into our rig and move that around, now there's one thing I forgot off the top of my head was I always forget to do it, that even though our input is constrained, we're not constraining our rig, so our component. So if we have a look at this and go into our input, you can see it's actually moved right here, right? So what we haven't done is attach the parent input to our actual control rig so that when we move this input, our control rig should follow along, right? So that's super easy to do. So if we now jump back into Python, go down into our setup rig, and at the bottom here, I'm just going to, I'm just going to essentially create a new variable called controls. And I'm just going to, actually, I'm going to call this SRTs. That's all we really need. If I just think about that. And SRTs is going to be control.SRT. So I think at this current stage, it's all we really need to do. And what we now can do is just go and say down SRT, SRTs, and it's going to be upper because it's the same ID as our control and ID, the actual ID that we're going to use. Now what we can do is go self.input like that, .input node, and actually I've already got that in on the completion because I've already done it. But what we can do is just connect up the world matrix plug to the parent of the actual SRT that we need. So in this case, we're just using the offset parent matrix because that's all we need. And we're just doing this in mod space because we don't have to worry about it because the actual SRT for our control is in mod space. Now, The last thing we have to do is reset the local matrix of our parent SRT because we've connected up the offset, but the SRT of our control local matrix is still where it's actually meant to be. So all we have to do is go reset, transform. Now you might question, why do we even need SRTs for this kind of situation? My general practice with rigs at the moment, especially with 5, is that I put SRTs on every single control temporarily until I know exactly how the component is going to act later on. So I might leave it for a few weeks, get it into production, get it running. Then what I'll do is go, okay, well, we actually don't need these specific SRTs on these controls because we don't need actually any space switching or any kind of behavior to deal with that SRT. So we can now strip that back. And that's where I would just go back into the code here and just strip that out. And then we're done. Now we're essentially got the input. And if we go back into Mile, open up, go back to guides, go to rig, and we fail, of course. So I did a bit of a boo-boo. So in our, you probably already noticed it when I was typing it, but I didn't notice it, is I just needed to specify key. Now, if we do that build again, Ori's code, that's okay, because I've got into a corrupted state after like failing a build halfway through. So now we just build two components, bring that together, do a build, so everything's working again. And now we have our setup. So we should still be able to do whatever we need to do here. And then with that, we've also got scale, right? So obviously non-uniform is never going to work unless you set up scale properly. In this case, we haven't set up scale properly for non-uniform scaling. So it's actually scaling very incorrectly, but non-uniform scaling globally is typically not supported by rigs anyway, so it's not too much of an issue. Once we've got that, what we now need to do is have outputs. We don't have any outputs, which means we can't take another component, for example, our arm, and we now can't just connect it up to our component here, right? So we can't take these two and parent them together and have everything to work, because now the arm has nothing to parent to because we have no outputs. So that's what we're going to do now. Let's set up our outputs in the definition the same way we did the inputs, but instead of only doing one of them, we're going to create an output for every essentially guide or joint. That way, because what we're going to do is take those outputs and constrain them to the joint. That way we get those joint transformations coming outwards, and then we can connect an arm to our component. So definition, once again, we're going to go for guide and definition, guide, layer, just literate guides, and don't, well, we're going to do that anyway in a second. And I'm going to get the output layer, definition output layer. So in this case, we also need to specify the parent. So the parent here is going to be the guide.parent, right? Because the only reason why this will work is because the order of the guides in the hierarchy is the same order that we're going to create our outputs. So we can actually just use the guide's parent ID for that as well. Sometimes you will have to actually customize that depending on kind of circumstances and so on, and how you actually deal with that is very dependent. FK, for example, has to actually do things like sorting and so on to try to figure out what the hierarchy is, to figure out what parent structure is going to be. This should be all good. So we load the guides. We check to see if the guide exists already. If it doesn't, then we're just going to create it. And as long as I didn't miss anything, that should be fine. The next thing we do is now constrain or set up our joints and our outputs so that everything is constrained together. And the way this ordering works when it comes to set up the inputs, set up the outputs, and the definition is that what happens is that set up inputs get called first, then the setup to form, which is going to be essentially set the form layer, right? So that one there, that gets called in between, then the setup gets called afterwards, which gives you the opportunity to essentially constrain your outputs to your joints. And that way you can send those transforms to the next component and do whatever else you want to do with the outputs. So just like the inputs, we need to do the same kind of setup we now need the deform layer because we're going to constrain the joints. We also are going to need an output layer from the scene itself because we're going to constrain it. And for now, that's going to be suffice. I'll talk about optimization of code in a moment, but not that it's really that important in this kind of case, but it's a good thing just to touch on overall. So what we're going to do is loop over our outputs. Now what we want to do is basically get our output in the same location as our joint. So easy way of doing this at this current stage is just going to say if index is equal to 0, and what we want is a joint now. So all we can do is deform joint. Leave that should be fine joint, but it could be as well. I keep forgetting which one. Now joint matrix plug to the offset output matrix. So all I'm going to do is go to output joint.attribute matrix, and then what we can do is connect that up to the offset matrix. And just for safety's sake, I'm also going to reset the loop matrix for the output. Now, as long as I did everything correctly, this should be perfectly fine. I'll talk about optimization of grabbing the output of the joints in a moment, because that's not the most performant thing to do the way that we've just done it there. It's not that important to worry about it unless it becomes a problem, but it is still a good idea for me to touch on that. So we'll get it in that moment. Now let's just check to see if our code is even valid, because I always forget if I did something right or wrong. Now all I'm going to do is just build our component to make sure the build works. Okay, so it builds, and if we go into our component and turn off black box, our outputs are created, and they are in the right spot. And if we have a look at our connections, you can see that each one of these outputs in the right place, they're all connected, they're all zeroed out as well. So we're good to go on all of this. So now if we go back to guides, I'm just going to create an arm and connect that up. Rig. Ignore that, that's just my UFE files with USD stuff, which is buggy. Now if I did a bit of a boot and constrained the joint to the SRT. So right here where we basically build a constraint for the parent constraint, we use the SRT to constrain the joint. That's wrong. So all you do is remove that and we're good to go. Now we have everything working. Glorious bugs. So now we're good to go. We should be able to build. Now we have everything working as we actually expected after I fixed the bug. And all that's kind of doing what it's supposed to do. And if we scale that up, we're not getting scale output. I've got to remember why. That's because we're not actually scaling the joints because we don't want to do that right now. That's perfectly fine. That's not a bug. That's just because I didn't integrate that. If you want to get scale to the joint as well, that's super easy. All you do is take the scale and change that to scale. And good to go. Right. Now, there's actually something else we want to do with this in a moment. But the other thing we want to just touch on for a bit is the optimization of code. Now, at the end of the day, when you are dealing with optimization of code, you don't optimize unless you know it's going to be a problem well before you actually do it, because you've got the experience of actually dealing with that. On the other front is you don't optimize unless you really actually know there's going to be optimization, like profiling, for example. Now, one thing you can do with Hive is what you'll find is if you try to retrieve a single node from Hive's meta network, it's actually slower to do that compared to just getting them all. And in this case, we actually need all the joints anyway. So if we actually have a look at the deform layer joint method, you can see it's basically just a for loop that iterates over a set of joints. I mean, attributes in Bayern's meta node. So this is a bit of a problem because this means that every time we loop over an output, we're looping over potentially the same set of attributes over and over again. Now, in this case, it's only 3 times, so that's basically that 9 iterations. That's not too much of an issue, but bigger components, more complex components, and typically when you need to do this multiple times in the same method, it's safer not to do that at all. Instead, just receive them all and just cache it into a dictionary, which is what I do most of the time. So what you can do, because the joint is the actual scene node, ID is a method, and we're just going to grab that from form layer, if I can spell. Basically, in this case, I'm just going to use it as a dictionary. You could do it as a list because it would be potentially most likely in the same order. The order that it comes back on is the same order that you create them. So if you've got like 3 nodes in sequence, the way it's going to be received when you query it is going to be the exact same order. Just be mindful when you have dynamic components, when you're deleting, adding, all that kind of stuff, is that you're actually changing the order of how things are going to be returned back from you from these methods. So the idea is not to rely on the actual methods, rely on IDs and lookups. So that's how you can potentially optimize some things. Obviously, this is kind of a micro optimization. It's probably not going to be most ideal. So just fix that bug that I just created. But the things you'll deal with in the future, just optimize when you can, when you need to, and after profiling and so on. Now, the other thing you want to deal with is metadata. Now, this is going to be a quick one. So what we've done is created constraints. The problem with these constraints is they're not tracked by the meta system. Now, when you delete your rig, it's going to be basically a fluke that your constraints are going to be added into the meta system and be deleted. So what we want to do is be absolutely explicit, be absolutely sure they get deleted at the right time. And it also means that you can query them to do things like renaming dynamically, so that when you run a method that does all your naming later on, you can actually query every single node in your entire component and rename them all in batch. Without this system, you're not going to be able to do this predictably. So all you have to do with build constraint, obviously you can use CMDS to do the constraint, it doesn't really matter, but everything that you need to do later on has to go back into our custom classes and so on. So first argument that gets returned from build constraints is the constraint class that builds it, and the other one is going to be the utilities. So it's going to return the utilities. Oops, I should do equals on that. And what we want to do is go to rig layer, add extra nodes, and I'm just going to go set the utilities on that. Right? So all we have to do is do the same thing. The other constraint, I'm just going to copy. I don't really mind about that. And as long as everything is good. And before I build it, I'll show you what I mean by this. So if we go into the DAG system here, and I'm just going to select, let's just go black box. So we have our constraint here that we created between the control and joint. And the problem with this is that it's not connected in terms of metadata. So you can see that it has a message attribute to this node, but we don't have it to our meta node. And we want all this accessible really quickly through the meta node. And that way we can do everything else, like from a coding point of view, query it, all that kind of stuff later on. So we can do that really easily by doing what we just did in code. So now if we just reload, just do a build, and I error because I probably did bad things. Auto completion is terrible sometimes. So just add extra nodes, not add constraint. So add extra nodes is going to add all that kind of stuff together. So now we do rebuild, check it, everything works. And if we go into the joint here, go into the node outliner, node editor, and we check to see what we got here. We have the parent constraint. We have the message attribute here, and now it goes into our rig layer. And if we open this guy up, you can see we have the extra nodes. All your extra nodes, like math nodes, constraints, all that kind of stuff. Anything that's not Hive specific goes straight into the extra nodes, and that allows all that kind of stuff to be tracked. It's the stuff that you don't need to worry about in regards to queries specifically. Like you don't need to worry about tag nodes. You don't need to have, they're not controls, they're not joints, that kind of stuff. Things that Hive should know about, that kind of thing. Now, there's one last thing we have to worry about, and that is converting from our data, from our code into the data. Because I said I was going to do that, so let's do it. I don't really like maintaining code so much, especially when it comes to things that are static. Now, I've talked about this before, which is definitions are essentially static, unless you're dealing purely in memory and like doing it in code. So in this case, we want to be able to take this input and these outputs and express them in the data, which means that all this code here disappears, right? Which is what we want, right? We just want to disappear all of that and be done with it. So we can actually do that pretty simply. I'm just going to move all of that down like so. And now if we go in our data, all we have to do is do the same thing that we've done for the other layers, which is create an input layer. It's a dictionary. We're going to have a tag, and that is going to be a list. And then inside here, if I just zoom in so you guys can see it a little bit better, sorry. We're going to do create an ID. So this is our input layer, and the ID is parent, and the name, we don't care about this right now. We'll deal with that a little bit later when we start doing naming conventions. The most important flag is going to be the root, and that's just going to be equal to true. Then we're going to create our output layer. Tag again, as per usual. We just need the ID. It's going to be the upper because that's going to be the output, and the parent. Don't need to worry about it for this guy. Name, I'm just going to say output for the time being. Temporarily, I'm going to specify a children, which if we just copy that, paste, and we just add a flag, which is for parent, which I still haven't actually rectified in the code base. Let's change that to mid. So we should be done. Let's look at it in. So we're in guides, and now we can just create our root. Everything still works, so we have nothing code-wise that doesn't error. But I'm just going to create a fresh one, and I'm just going to go root, and I'm just going to make sure that our outputs get created. So we created all our outputs. They're still in the right spot. They're parented correctly. We created our input. It's in the right spot. Now we're essentially done here in terms of the main connections, and you actually have a working component now. There is still some missing things, but the overall arcing problem with this component and not being ready to go is now done. We are going to focus on a few other things now in the next set of videos. And one of those is we need a custom UI. Well, we don't, but we're going to go through that so you know how that works. So in this case, we want to be able to have a custom UI here, very similar to like our ARM. We have options here, so that's going to be useful for you. We have advanced settings. We have space switching. Like if we go space switching here, we have that. We have really no space switching here, right? So if you come here, we have space switching, no space switching. Why is that, and how do we work with that? How do we actually define space switching? And that's what we're going to actually do in the next video, which is all about space switching and setting all that kind of stuff up, how it looks. We're not going to, probably won't dive super deep into that, how the data works with space switching and templates and so on, but I will go through how to set it all up. The other thing that this component is missing, not just space switching, but also naming conventions. We haven't set up custom naming conventions. Technically, it's not necessary unless you really need to, but it's a really good idea to do so. And that means that we need to be able to go and say, okay, these are my inputs, outputs that I want these names for. These are going to have these expressions, so it's going to be accessible in the UI. Because if we go into our UI right now, in our, let's say, naming convention UI, we do not have our custom component in here. So that's a problem. We're going to definitely need that. So we have to deal with that as well. The other thing is, while it's not important for our current component, we also need to deal with ID mapping, which is a really useful thing. Certain components like the guard node and so on does have ID mapping that remaps IDs from one layer to another. I will definitely go into that because it can be a bit of a mind bender in terms of why that's important. Until you actually hit the problem, then it becomes a problem, like really important stuff. The other thing is settings. So how do you deal with settings like, for example, the ARM, like has stretch and so on? How does that correspond to the UI and all that kind of stuff? There's so many things to go through. We even haven't touched more complex components like dynamic components. So that's it for this video, and I'll see you in the next one.